from LJ Institute of Engineering and Technology. Today's session we are going to discuss about Fourier series. Let's move to our class. In earlier lecture we are already discussed about examples of Fourier series. Today's session we are going to discuss about even and odd function. First of all, what is even function and what is odd function? These things you already learned in 11-12 science. First of all, if given function is even, then first of all, how we can identify given function is even or odd? Then we replace x as a minus x and we get both has same value of function. Then we can say that given function is even. For example, suppose function f of x equal to x square. In this equation we replace x as a minus x. Then f of minus x, then we can say that f of minus x whole square. Then we get f of x square. If we replace f of x equal to minus x, then also we get same as original function which is given in question, means x square. Then here we can say that f of x, then f of minus x equal to f of x. Then we can say that given function is even. Similarly, suppose f of x equal to cos x. Then we replace x as a minus x. Then cos of minus x. But we know that cos of minus theta equal to cos theta and sin of minus theta equal to minus sin theta. Then here we get again cos x. Then we can say that f of minus x equal to f of x. Then we can say that given function is even. If function is even, then we put directly bn equal to 0. No need to solve bn. Then formula of a0 and an, then integral. In above formula we use 1 upon pi integral f of x dx. First thing, which type of example we can find even and odd function? Then if our function has a limit is symmetric, then how we can identify limit is symmetric or not? Means minus pi less than x less than pi, minus 2 pi less than x less than 2 pi, minus 2 less than x less than 2, minus 1 less than x less than 1. This type of limit which is given in question, then we can say that given limit is symmetric. Means starting and ending range is same, but only change in sign, positive sign as well as negative sign. This type of limit which is given in question, then and then we can solve as an even and odd of the function. Then first we identify function is even or not. Then we go for example. Suppose here we have limit in terms of minus pi to pi. Then we will finding if function is even. Then a0 equal to here 2 by pi. Means we have limit minus pi to pi. Here 0. According to the line segment. Then we will find this particular position on here. And whatever the answer at this position, we multiply with 2. Then multiply with 2 by pi. And limit which is 0 to pi. Here our question has a minus pi to pi. Then we can solve with 0 to pi f of x dx. Similarly, n equal to again 2 by pi, limit which is 0 to pi f of x cos nx dx, and bn which is 0. Then Fourier series equal to a0 by 2 plus summation n equal to 1 to infinite an cos nx. But bn is a 0, then 0 into anything 0. Then substitute the values of a0 and an in this equation. Suppose function is odd. If function is odd, means replace x as a minus x and we get f of minus x equal to minus f of x, then we can say that given function is a odd function. For example, f of x equal to x cube, then replace x as a minus x, then minus x whole cube, then we get minus x cube. Then here f of minus x equal to minus common, and this is our original question, that is f of x. Then if f of minus x equal to minus f of x, then we can say that given function is a odd. Similarly, for example, f of x equal to sin x, then replace x as a minus x, then sin of minus x, sin of minus theta equal to minus sin theta, then we can say that minus f of x. Then sin is a odd function. If function is odd, here we consider as a minus pi is z, x is z, pi. Then we put directly a0 equal to 0, an equal to 0. No need to find a0 and an. Just directly go for bn. Then bn equal to, here we have then is minus pi, 0 and pi. Then we just find for this particular position, this particular range or limit, and multiply with 2. Then limit is 2 by pi and limit of integral is 0 to pi f of x sin nx dx. And Fourier series is f of x equal to summation n equal to 1 to infinite bn sin nx. Just find value of bn, substitute the value of bn in this equation, then we get Fourier series. These are the formulas for finding the Fourier series with the help of even and odd function. Let's start with one counter example to better understanding the concept of even function and odd function. Find the Fourier series of function f of x equal to 1 plus 2x by pi. Here 1 minus 2x by pi. Interval of x is minus pi less than x less than 0, 0 less than x less than pi. Also deduce that 1 upon 1 square, 1 upon 3 square, 1 upon 5 square and so on equal to pi square by 8. Then first of all, we have identify given function is even or odd. First of all, to identification of even or odd, we will check limit of function is or interval of function is symmetric or not. Then after we go for even function and odd function. Then also we check even and odd function. Here starting range is minus pi and ending interval is pi. Then we can say that our range of interval is minus pi to pi. Then we have to check given function is even or not. Then consider any one function. Suppose f of x equal to 1 plus 2x by pi. Then replace x as a minus x. Then we get minus 2x by pi. That is also function. Then here f of minus x equal to f of x. Then we can say that given function is even. Similarly, you have to check another function f of x equal to 1 minus 2x by pi. Then replace x as a minus x. Then we get 2x by pi, which is also f of x. Then we can say that also given function is even function. No need to solve. You have to solve this one portion, otherwise this one portion. No need to solve the both. Now, if function is even, then we could directly be at 0. Then a is equal to multiply with 2. Then formula is 2 by pi. And half of the interval, means interval is minus pi to pi. Then we consider only 0 to pi. 0 to pi f of x dx. Then at this particular range 0 to pi, in this range function having value 1 minus 2x by pi, then substitute the values of 1 minus 2x by pi dx and integral this term. One that is x, here 2x square by 2, 0 to pi, 2 which is cancel out, here 2 pi pi, here pi square pi, 1 pi which is cancel out, minus upper limit minus lower limit 0, pi minus pi 0, then we get value of a0, that is 0. Similarly, you can find an, that an equal to 2 pi integral 0 to pi f of x cos nx dx. Now substitute the value here 2 by pi integral 0 to pi f of x at 0 to pi interval has a function is 1 minus 2x by pi, here cos nx dx. Then we use Bernoulli's equation for multiplication rule of integration. Then this term which is indicated by u, this term which is indicated by v according to the Lied. Then integral u as it is, integral of v means sin nx by n minus derivative of u means we get minus 2 by pi, integral of this one, then minus cos nx upon n square. Here 0 to pi, this one which is constant, derivative constant is 0, then 0 into anything 0. Now upper limit minus lower limit, then here we replace pi, then value of sin nπ is 0. What is value of sin nπ? 0. Cos nπ minus 1 raised to n, cos 0 1, sin 0 0, sin 2nπ 0, cos 2nπ 1, which is already learned in earlier lecture. Then sin nπ is 0, then 0 into anything 0, minus minus minus, then 3 times minus, then minus 2 by pi cos nπ minus 1 raised to n upon n square, minus lower limit 0, then sin 0 0, 0 into anything 0, 3 times minus, then minus cos 0 1, then 2 by pi n square. Then here we get 2 by pi minus 2 minus 1 raised to n upon pi n square, minus minus plus 2 by pi n square. Then here 2 by pi n square which is common, then we get 2 2s are 4 by pi square n square. Then we get 1 minus 1 raised to n, that is value of n. Now substitute values of that is value of an, because here function is even, then bn is a 0. Now substitute this value in our formula of Fourier series. And Fourier series is here f of x equal to a0 by 2 plus summation n equal to 1 to infinite a cos nx. Now substitute the values of a0 that is 0. Here f of x summation n equal to 1 to infinite an, then an equal to for 1 minus 1 raised to n upon pi square n square into cos nx. Here given function is a discontinuous function. Earlier lecture I already explained about what is discontinuous function. Means here in range of x is minus pi to 0, function having value 1 plus 2x by pi, and 0 to pi, function having value 1 minus 2x by pi. Then what about 0 position? We cannot identify for this function directly at position 0. Then we will find the value of function at 0 position. Then means we can say that given function is discontinuous at x equal to 0 position. Then we have to find value of function at 0 position, that is 1/2 limit x tends to 0 minus f of x plus limit x tends to 0 plus f of x. Means before the 0 and after the 0 minus means before the 0 function having value 1 plus 2x by 5. Then at this function we replace x as a 0. Then 0 into anything 0. Then we have value of function is 1. Here after the 0, then 0 plus position, function having value 1 minus 2x by pi. At this position we replace x as a 0. Then 2 into 0, 0. Then 1 minus 0, that is again 1. Then 1 plus 1, that is 2 by 2, that is cancelled. Then at 0 position, function having value is 1. For reducing this value, we require value of f of 0. Then here at x equal to 0, substitute the values of x equal to 0 in this series. Then f of 0, summation n equal to 1 to infinite for 1 minus 1 raised to n upon pi square n square. Here cos 0. Then cos 0, that is 1. F of 0, that is also 1. Then 1 equal to summation n equal to 1 to infinite for 1 minus 1 raised to n upon pi square n square cos 0, that is 1. This pi square and 4, this comes this side, right hand side portion. Then we get pi square by 4 equal to summation n equal to 1 to infinite 1 minus 1 raised to n upon n square. Now just expand this term, means substituting the n equal to 1, 2, 3 and so on. Then we get here pi square by 4, substituting the n equal to 1, then 1 minus 1 raised to 1, that is minus 1, then minus plus, then we get here 2 by 1 square. Here substituting the n equal to 2, then minus 1 square, 1 minus 1, 0 into anything 0. Then again substituting n equal to 3, then we get again n equal to 4, then 0. then 5, then this, then 6, then 7, and so on. Then in numerator portion, 2 which is common, then we get 1 upon 1 square, 3 square, 5 square, and so on. This 2 comes this side, then we get pi square by 8 equal to 1 upon 1 square, 3 square, 5 square, and so on. This term in generalized term, we can also write n equal to 1 to infinite 1 upon 2n minus 1 whole square. Here, this example we find with the help of even and odd function. Suppose I cannot understand about even and odd function, then this example we can solve above the method. Above method we can find a0, an and bn with whole limit, means minus pi to 0 as a function this, and 0 to pi function this. This type of example I already learned in above lecture. You can see it first, then after you can solve this example. Next example is find the Fourier series of the function. Fourier series of the function f of x equal to minus k and k. Here interval is minus pi less than x less than 0, 0 less than x less than pi. First of all, we have to check given interval is symmetric or not. Then here lower limit is minus pi and upper limit is pi. Means range of interval is minus pi to pi. Then limit is symmetric. If limit is symmetric, then and then we just check given function is even or odd. And in this example, we have to find even and odd function with the help of graphical representation. Here minus pi, here pi. Interval of minus pi to 0, function having value minus k. That is the position of minus pi. And value is minus k, and 0 to pi function having value is k, means here 0, then 0 to pi, that is our suppose function. Then if we replace x as a minus x, then that is our f of minus x, means according to this diagram we can say that f of minus x equal to minus f of x. This condition is satisfied. Then we can say that given function is odd. Suppose, for example, suppose we have function. This is the value, here 0, here pi, and here minus pi. This one is our f of x, and this one is our f of minus x. Then we can say that f of x equal to f of minus x condition will be satisfied, and this type of graphical representation given in question, then we can say that given function is even. Means here, suppose this position is minus pi by 2, this position is plus pi by 2. Plus pi by 2, function having value is k, then minus pi by 2, function having value is minus k, means here x position is equal to k or here minus k, then we can say that f of x equal to f of minus x. Then given function is odd. If function is odd, given function is odd, if function is odd, then a0 equal to 0 and an equal to 0, no need to solve. We just put it directly 0 and solving only bn. Then we have formula for bn. Then multiply with 2, means 2 by pi integral n half of the limit is 0 to pi f of x. Here Bn, that is sin nx dx. Now here 2 by pi integral 0 to pi, function value is k sin nx dx. The integral of this term 2 by pi k, which is constant. Integral of cos z is sin, that is minus cos nx 0 to pi. Then here 2k by pi n, upper limit minus lower limit. Then what is the value of cos n pi? Then minus 1 raised to n sin n pi 0 cos 0 1 sin 0 0. Then substitute the value. Then minus, which is common, cos of n pi. Then minus 1 raised to n cos 0 1, minus comes inside the brackets. Then 2k by pi n, here 1 minus 1 raised to n, that is value of Vn. Now substitute the values of Vn in Fourier series. Then Fourier series is, that is f of x equal to summation n equal to 1 to infinite Vn sin nx. Here summation n equal to 1 to infinite, value of Vn, that is 2k by pi n 1 minus 1 raised to n into sin nx. That is our Fourier series. No need to expand. If our question has reduced this type of question, then and then we just expand the Fourier series and substitute the values of something x, and we get whatever the values that given in question. In even and odd function, means if function is even, then a0 and an we find it, and value of an is 0. If function is odd, then a0 and an 0, and we just find the bn and substitute these values in our Fourier series formula. If you have any doubts regarding this topic, then feel free contact me. Thank you so much for listening me.